All right. Wait, what happened? Uh-huh. All right. So, you guys should have your Unit 2, Section 2 journals, your IDS practice book. If you're using your practice book, pages 78 and 79 are what we need for today. Okay. And of course, be logged into our studio. You do have a small homework assignment, 2.9 histograms of a die. You'll be needing to sketch histograms, so you can probably do that by hand and then take a picture and upload it to the document for that assignment. Okay, we're talking about lesson 9 today. Lesson 9 is called bias detective. Okay, bias means having leaning toward one side or the other, right? And not having a fair opinion or a fair outcome. In this situation, you're not being biased as a detective. Instead, you're a detective trying to find the bias. Okay. And when we talk about bias here, we're talking about the bias in probability, right? So what we have here is we have our objective. So the main objective is that you will learn how to use simulations in our studio to detect biased probability. Our essential concepts for the lesson is that in the short term, actual outcomes of chance experiments, they vary from what is ideal, right? So in the short term, meaning like if we flipped a coin 10 times, or if we flipped a coin 20 times, or even 100 times, that's still considered short term in relation to what we mean by ideal. When we talk about ideal probability or theoretical probability, we're talking about the long run, that infinity. If things kept being done, this is what it would eventually come out to be, right? It would come out to be the expected value. So an ideal die, right, a singular die, has equally likely outcomes, but that does not mean that we will see exactly the same number of 1 dots, 2 dots, 3 dots, and so on every time we roll the die. So each side of a die has an equal likelihood of being landed on, but that doesn't mean that if I roll the dice, like 50 times, that I'm going to see the numbers the same number of times, right? Because that's real life. All right, so first things first, we're going to go to our IDS journal. First question on there actually has you refer back to lesson 8. So in lesson 8, we had, you guys had a homework assignment where you had to write a tweet to answer the question of what is probability. It's okay, okay? I want you guys to look back at your tweet, think about it, and compare it to the following concept, that probability is the measure of how often something occurs in the long run, right? So we're talking like a million flips. We're talking like infinitely many flips, long run, not short term, okay? So when we talk about probability, especially that ideal or that theoretical probability, we're talking about the expectations, the probability of something happening in the long run, okay? So the question is in the tweet that you wrote, does your tweet include this description or something along this description? If yes, great. If not, I want you guys to adjust your tweet. And if you did include something like this, then make sure that this statement is written down in your journal at the very least. Okay. Ah, okay. Okay. So you might want to add this to your tweet, or at least to your journal. Hey, Daniel. Okay, so I'll give you guys about a minute more. Okay, we have 20 more seconds. All right. So during our last lesson, lesson 8, right, we talked about the ideas of chance, we talked about probability, and we talked about simulations, okay? And we used simulations to calculate sample proportions, right? And we estimated probabilities of real life events like flipping a coin. Today, we're going to be using simulations to show, or we're going to learn about how probability and simulations can be used to determine if something is biased or not, or if it's fair or not fair, right? So for example, when a coin is weighted and therefore lands on heads more than tails, it's considered a biased coin or a not fair coin. Right. So that would consider it a not fair coin. Yeah. Because there's essentially cheating, right, involved. Okay? There's no longer a 50-50 chance because you're altering the probability of it landing on one side more. Yeah. Okay. So let's talk about the idea of what is fair. What is an actual fair thing, right? So I want you guys to think about dice, okay, the numbered cubes. A die, which is the singular, right? It's a single number cube. It has 6 sides. Okay, so a die is a 6-sided cube. Each face of the cube is labeled with dots to represent a number between 1 and 6. So for example, if the face has 3 dots, then it represents the number 3. If it has 5 dots, it represents the number 5, and so on. A fair cube, a cube that is fair, that is not altered in any way, right? A fair cube is weighted so that there is an equal probability of rolling each of the 6 numbers. So dice makers have to be really careful with how they make their dice so that it is balanced, right? And it has an equal probability of landing on whatever side. It's not more weighted on one side of the die or one corner of the die than another. That's why casinos are very particular of where they buy their dice from and what companies that they use, as well as the cards that they use. They do. There are trick dice. They're called loaded dice, right? So one type of trick dice are loaded dice. Other ways you can shave off weight, right, from the die or the dice to make it skew toward one side more. Like, yeah. All right, I'll give you guys another minute to finish writing these notes. There's more. Okay, all right. So thinking about this idea that a cube, right, a die is a fair die, I want you to think about what would you expect the probability to be of getting one, right, of landing on a one, if you were just to grab a die, toss it up in the air and let it fall, right? What would you expect the probability of getting a one to be? This goes for you guys at home too, right? Every question I ask is for you guys at home as well. So what is the probability of getting a one, right, for a fair dice? You didn't do anything to throw it a certain way, right? That's where that whole process means, like throwing it up in the air and letting it fall. You're not altering it in any way. It's a fair toss, you know. What would you think the probability would be of getting a one? Okay, so 1 out of 6 chances, or 1/6. Why? Are you guys hearing Lamaya? Can you hear Lamaya? Nice. Hi. Oh, help me, they can't. Oh, that's a problem. A little. Andrew says a little. All right. So yes, guys, very good. So there are 6 sides. Okay. There's only one in a fair dice. It's not that there will be multiple ones. Good. Okay. Kind of like bear. Okay. So for you hearing you, got it. So Lamaya was saying the same thing, right? She was saying there's 6 sides and there's only one side that has a 1. So it's 1 out of 6, right? What do you think the probability would be of getting well, a 3 out of 6? Or I'm sorry, what would you say the probability is of getting a 3? Okay, good. Yes, right. Good. Yes, Hector. A would still be 1 out of 6, right? Because there's only one side that has a 3 on. And the same is true for landing on a 5. The same is true for landing on a 4 or 2, right? Or 6. There's only one side with that number. So it's still 1 out of 6 because there's 6 sides. Okay, very good. Okay. So now we're gonna have a whole class discussion, which pretty much means that you guys at home are gonna be chatting it up, and I have the chat up on the screen, so Lamaya can see the chat too. She's not on our Zoom, right? So I have the chat up on the screen, so try not to private message me. And we're gonna have a quick whole class discussion for the following questions here. Okay, so here we go. So we're gonna consider a scenario. It says, since you will be rolling 2 online dice 6 times, there will actually be 12 rolls for our sample. So we're gonna take 2 online dice, okay, and we're gonna roll it 6 times. So we're rolling 2 dice 6 times. So in reality, you're getting 12 rolls, right? Because 2 rolls each time. So before we roll the dice, let's talk about the following questions. Okay, if you were rolling the dice 6 times, how often will the die on the left roll a 3? How often would you expect, okay, the die on the left to roll a 3? 2. Right, but what if we're just looking at the left die, just one die? How often would you expect to roll a 3? Okay, so 1 out of 6 chance. So 6 rolls, right, with the left die. So out of those 6 rolls, you would expect to get at least 1 3, or like a 3 one time. Yeah. Okay. What do you guys think? Oh, my bad. Wrong thing. So Lamaya is saying that you should get 1 3. Okay, 1 out of 6 chance. Okay. So out of 6 rolls, we should get 1 3. Yeah. At the least. Okay. Is that the same? Would you have the same idea for the right dice? Does anything change just because it's the dice on the right? Okay, so if the dice are fair, okay, then we should have the same expectations, right? Whether it's the left dice or the right dice, we should still have the same expectation. Okay. Would you expect the dice on the right to roll a 3 just as, wait, we just answered that question. Never mind. Moving on. Okay. So let me ask you this. So if we roll something 6 times, like a die, right? The expectation is that we get each number once, right? So 6 rolls, each number has a 1 out of 6 chance, right? So the expectation is that we should get each number once, right? Okay, so you're talking real life. I'm talking theoretically. Theoretically, right? Theoretically, ideally, if I do 6 rolls and I have a 6-sided die, I should get each number once. Okay. What if I did 12 rolls? How many times should I get each number? Okay, twice. Would you guys agree? Good. Yes. Hector, Zoe, right on. Okay. So Hector and Zoe agree completely. So what if I did 18 rolls? Yes, 18. So I would get each number 3 times, right? Ideally, the expectation is that since I have a 1 out of 6 chance for each side, every 6 rolls, I should get each number, right? Yeah, tripling it, quadrupling it, right? Yeah, multiplying it essentially. So what we're gonna do, ladies and gents, is we are going to roll our dice, okay? So before I give you or I release you to do this, let me go through the directions, okay? You are going to be looking at your IDS journal. Okay, your IDS journal is, let me share it real quick. Okay. So on your IDS journal, you should see, I'm scrolling. Okay, you should see this table here with a 1, 2, 3, 4, 5, 6, right? And there's a link here. The link doesn't work, so don't try it. I'm gonna give you guys a different link. The link you're gonna go to, Lamaya, is that second one right there. Yeah, okay. So what you guys are gonna do is you are going to roll a pair of dice, okay, 6 times. So you're gonna roll 2 dice 6 times. So that's a total of 12 rolls, right? 2 dice 6 times, that's a total of 12 rolls. So each time you roll the dice, you are going to tally the numbers that you get. So suppose I roll my dice and I get a 2 and a 5. So then I'll come here under 2 and I'll put a tally. And then I'll come here under 5 and I'll put a tally. And then I'm going to repeat that 5 more times, right? So a total of 6 rolls of 2 dice, which means that you should have a total of 12 tallies among your numbers here, right? Two dice rolled 6 times, that's 12 tallies, okay? So you are going to do that and then tally it up, and we're going to see what we get. So we just said that the expected amount, right, if we roll 12 times, is that we get each number twice. That's the expectation. Let's see what the reality is, okay? For you guys at home, I'm going to go ahead and give you, hold on, I can't find my website. Here we go. Let me send you guys the link that you're going to be using instead of the one in your journal. Here you go. So it is random.org/dice. So make sure that the drop-down menu has 2 in it for roll two virtual dice. Okay, and you're gonna roll your dice and tally it, a total of 6 rolls, and you should have a total of 12 tallies. Okay, are there any questions about what's expected here? Okay, I'm gonna give you guys 2 minutes to do this. 2 minutes to roll your dice 6 times and tally it up. Yes. 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 So every roll that you get, you should be tallying 2 numbers. Okay, we are almost done here. Time is almost up. Okay. So keep that in mind. Okay, we're going to discuss that. So hopefully you guys were able to do your 6 rolls of the 2 dice and you have your 12 tallies. So let's take a look at the following questions here. This is a discussion, so those of you in the chat, please get yourselves ready. Keep in mind, I am keeping track of who is participating and who is not. Okay. So first question. Okay, we expected each number to roll twice, right? That was the expected probability, or that was the expected outcome. Okay. Does that match what you guys got? Does the data from your 12 rolls meet what match what you guys expected? Okay. Good. So I'm seeing no's. Lamaya said no too. Hector, you got 2s for every single one? Ha 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 ha. Okay. Interesting. All right. So if your data didn't, well, let's actually talk about that. Lamaya, you said you didn't get any for which one? So Lamaya didn't get any rolls for 2. What about you guys? Were there, Jordan said he never landed on a 1. What about the rest of you guys? Were there any anomalies that you're like, whoa, either it landed a lot or it didn't land at all? Okay, so Maya got a lot of 1s, 4s, and 6s. Wow, you got 3 and 4 twice in a row. 6 and 4, okay. Ash got mostly 6s. Zoe didn't get any 5s. Ash didn't get any 2s. Andrew didn't get any 2s and got 3 twice, okay. Interesting, interesting, okay. Good, okay. So does this mean the dice in the system were biased? Does it mean that they were unfair in any way? Okay. So no non-biased, no? Actually feel it? Okay. Okay, let me ask you this. Do you think there was enough information here for you actually to be able to tell that if they were biased or non-biased? Do you think we did enough trials?
Yeah.
So you think six rolls is enough to tell?
I mean, I don't know.
Okay, well, sometimes you can.
I mean, yeah.
Lamai said Wikipedia is always wrong. Okay. Okay, so one of the cool things, right, is we can do the rolling the dice in the system in the random.org. We can do that over and over and over again. However, if we wanted to roll our dice, I don't know, 100, 500 times, we can, without having to press the button over and over again, we could go to RStudio and use RStudio codes. Excuse me. So similar to our previous day's lesson with the coin flipping, you can also simulate dice rolls in RStudio. The function required is called roll underscore die. That's the function, roll underscore die. So it only rolls one die at a time, right? So we're going to be using this function. I'm going to give you guys a few seconds to get this down because you want to write down the coding. All right. So with RStudio, the cool thing is that RStudio doesn't only have one dice in there or one die in there. One die in RStudio, okay, in the function is fair, and the other has been created with bias. So there's two dice, right? There's two dice in RStudio. One is called A, one is called B. One of them is a fair die, the other is an unfair die. So it's a die with bias. And the coding is written for it to be biased, okay? We're going to go ahead and in this lesson, we're going to attempt to figure out which one of the die is biased and which one is not. Okay, so which one is biased and which one is fair, essentially, okay? And we're gonna do this through multiple simulations. Okay, so first thing that we wanna do is we wanna understand our code. Okay, we're gonna understand our code. So in our last lesson, right, we did R flip, and R flip was simple. We would just do R flip, and then we would, in the parentheses, we would just write how many times we wanted it to flip the coin. But with the roll die, we can't just put roll die one. That's not how it works. Because there's two different die at play here, right? We have to indicate if we want it to roll die A or die B. So the codes that we'll be using are roll underscore die, and then in the argument area, we're gonna write in quotations, A for die A, B for die B, and then comma times equals however many times we wanted to roll the die. Okay? So after you guys get this down, I want you to go to RStudio and put in these codes and roll each of the die once. Okay, roll each of your die once. Okay, so I'm gonna give you guys 2 minutes to get these notes down and then go and roll the die in your RStudio. Interesting. Hey, Denelson is also supposed to be here for hybrid. Interesting. And yet he is not. Okay. So I hope you guys got a chance to go ahead and roll your dice each once. Lamaya's saying that she thinks that she already knows which one the biased one is, but I think she doesn't have information yet. Doesn't have enough information. Okay. So what we're gonna do right now is we're gonna kind of focus on die A. Okay. Because rolling the die once, right, is kind of is whatever. Okay. So now I want you guys to actually go to our studio and I want you to roll die A 12 times. And then you're going to compare it to the results of the simulation that we did on the website. Go to our studio and roll your die A 12 times. And I want you guys to tally the results in the same chart, but like do it on a different line. Does that make sense? So tally your results in your journal, but do it on a different line. Like go to another line and then tally the results from this roll. They could be similar. Okay. What happened? Go to the end of your tally and hit enter. Should go to another line. Or do you mean like a tab? Or you want to do the whole other? So you right click on the table, okay. All right, I'll give you guys another minute for your tally. Thank you, you guys, for letting me know when you're done with your tally there. Okay, Ash, Andrew, Keon, Jordan. Thank you for that. Apparently, I can't drink water. All right, well done, guys. Well done. Okay, so on that note, right, compare them. Are they similar? Are they very different? Were your results from the website, okay, were they very different, right? Compare your results. I want you guys to think about that. Compare your results from the website to our studio. Okay. So, let's see. Wow, we definitely have time. What is? Mm-hmm. Okay. Okay. So you were able to land on at least or most of the numbers at least once. Okay. Okay. What do you guys think as far as a comparison between the two? Do you think that dice A is let's make a conjecture, right? We don't have the proof yet, but let's make a conjecture. Do we think dice A is going to be fair or biased? What do you guys think? Oh, interesting. Okay. Yeah. Okay. Okay. Yeah. Okay. Let me put it to you this way. What would be we see if we had a biased die? A biased or an unbiased? Remember, biased is the one that they're cheating with, right? Okay. So Lamaya is on to a good point, right? She's saying of the biased die, you would land on a number way more often than you do other numbers. So in order for us to see a bias in the die, we need to see if there are any numbers that we're landing on way more than other numbers, right? So that's what we're looking here when we say we want to see a biased die. So what if we were to roll our die 100 times? Well, what if we were to roll our die 100 times? How would you record this data? If you rolled your die 100 times, how would you record the data? Would you tally it? Would you count it? What would you do? And then I also want you to think about this. How do you think our studio counts the simulation results? Think about a function that we use in our studio that would count the outcomes for us. Okay, so first question, how can you record the data? How would you record your data if you roll the die 100 times? And second question is how would you count the results of the simulation in our studio? Okay, I'm going to give you guys 2 minutes to answer these questions in your IDS journal. Okay, let's see. You guys at home, what would you answer? How would you record the data? What would you do? Okay, Jordan, tally marks. Anyone else?
I will
Ah, I like it. Okay, I don't know if you guys heard that, but Andrew just confirmed, agrees with you. Lamaya was saying how histogram would really help to visualize, right? How much you're landing on each number and be able to compare the frequency. Right on. And I see a lot of you, Zoe said a plot chart. Ash also said we can use graphs, absolutely. Daniel said tally as well. Hector said how write down how many each is landing on. So I'm assuming you mean tally, Hector. And then Annie was also all about that histogram life. Yes, we're going to be using histograms today, absolutely. Okay, and of course, since you're tallying, right, our studio actually has the tally function, right? So it'll actually count it for you. But there's codes, there's certain codes we have to do. So this is a really great page to write down notes in, guys. This right here, you should really put down. And I think I'm gonna let you guys write this down before I talk about it, okay? So I'll give you guys 2 minutes to write down. The codes are really important to write down, as well as what they mean and what they're gonna do for you. I'll make the codes a little bit bigger here, Maya, just in case you need it. I see you got your glasses on. Okay, and for you guys at home too. So I'll give you guys 2 minutes to get down these notes, and then I'll talk about them. All right, almost there? Okay, perfect. So our studio's tally function can count the number of times each of the values appears in our simulation, okay? But in order to make and use the tally function easier, we have to assign a name to each simulation and the results that we get, because that way it knows what group of data to actually count, right? So we have to assign a name to our simulation. And then we can do tally of that name, right, which is all those values. And then we can even look at we can ask for it to give us the proportion. So instead of giving us the count, it'll give us the proportion, right? So the decimal of how much it appeared out of how many times we actually did the simulation. So if we take each one of these and we put it into our studio, we can actually see this happen. So I'm going to do, I'm going to share my RStudio page with you guys here. Okay, let me move this over here. I hope you guys can see it. Wait, hold on. Resume share. Okay, so over here, you're going to see, okay, we're going to do, so we can call our simulation anything we want. Okay, so we can call it sample A, we can call it sample 1, we can call it A results, you know, whatever. So in this case, we're going to call it sample 1. So whatever the name is going to be, that's what you put first, and then you put the little less than and the dash, and you put your function. So we're going to do roll underscore die. Okay, and we're rolling die A, and we're going to actually roll it 100 times. Okay, so I'm putting in the first line of code, right? Hit enter. And you're like, Miss K, nothing came up. It's not there, Miss K. I don't see it. Actually, you do. So instead of giving it to you down here, what it did is look in your environment pane under values. You should see sample 1. And you should see that there's 1 to 100 values, and it's all listed right here. All of the results of your sample of those 100 rolls are listed right there. Okay. So then, now that you have essentially a variable or like a data set that it can pull from, you're now going to tally it. So I can do tally, and I can just use sample 1, the name of that data set. Okay, the name of that set of numbers, right? So tally 1, close parentheses, or tally sample 1, I'm sorry, hit enter, and it's going to give me a count of how many times 1 showed up, how many times 2 showed up, and 3, and 4, and 5, and 6, okay? So I can see that 1 showed up 9 times for me, 2 showed up 19 times, and so on and so forth, okay? And then if I were to do the tally function, I do the tally function, but I add a little modification to it. And after sample 1, I do format equals, and then quotations proportion. Okay, that is going to give me the decimal proportion of how often each number showed up comparably to the other numbers. So instead of giving me a 9, it says 0.09, 0.19. This is great for when you're doing it like not something out of 100, because we can easily see decimals in the hundreds, right? But when you do it out of like 200 or 500, that way it'll give you your proportion and you can actually compare the proportions, okay? In this case, I'm kind of seeing I got a lot of 5s and 6s. The 2, 3s, and 4s are really close to the expected proportion. The expected proportion is like 0.16, right? Because 1 out of 6 is about 0.16. So the expected proportion is about 0.16, and 2, 3, and 4 are pretty close to that. 1, 5, and 6 for me are a little bit high or low, but for you guys, it might be right on point. For you guys, it might be pretty close to the 0.16. Okay? So you never know. You never know. Ever, ever, ever. Okay, give me a second. Let me help coding. What's happening? All right, eyes back. Y'all gotta ask me more questions, because that way I get up out of the seat. Oh. All right, so our tally, right? But again, before we can tally, we actually have to name the simulation, the results of the simulation, so that we can actually tell tell RStudio what to tally, right? So every time you do a simulation that you want it tallied, you got to give it a name. And it can be any name. You can call it Joe. As long as you know what Joe means, right? As long as you know what Joe means, you can call it Joe. All right. Let's go back to our PowerPoint here. Okay. So understanding this concept of fair, okay? Remember, if our die is fair, then each side of the die should appear roughly about the same amount of times. Therefore, the proportions should be fairly similar to each other and to the true probability of 1/6. So this is what I was talking about, right? 1/6 comes out to about 0.16667. So for this, so most of our probabilities there in our studio should be close to 0.16, right? They should be pretty close. And by close, I don't mean like 0.15 and 0.17. It could be a little bit, it could be 0.13, 0.14, 0.15, 0.17. As long as it's in a little bit of a range, yes, right? Now, if it goes into like the 0.3s and the 0.4s, then we got an issue, right? So I'll let you guys finish writing this. Where are we? All right. You got it? Perfect. Okay. So in your journal, okay, I want you guys, so you said you would like to see it in a histogram, right? So let's make a histogram of our tallies. Okay, so based on what your tallies were for your roll of 100 times, I want you guys to draw an actual histogram. Okay, and I'm gonna do one of mine so you guys can kind of see what we're talking about. We're just gonna sketch it. You know, it doesn't have to be perfect. It doesn't have to be, you know, beautiful. Ain't nobody giving you an art present, or what is it, an art scholarship here. Okay, so it doesn't have to be beautiful. It can just be a quick sketch. Okay, so I'm going to annotate here, bring this over. Okay, so first thing I want to do is I actually want to take a look at my RStudio, and I want to write down these numbers for me so I can actually use them. So I have a 9, so I have 9 ones. I'm just going to write them in order and I'll know which one I'm talking about here. Okay, and so now we're going to go back to our PowerPoint here. Right there. I should be sharing my screen on my PowerPoint, right? Yes. Okay. All right. Oh, that was not smart. Come on. We all have different ones, yes. Yeah, we all have different. Yeah, no. We all have a different, which is the beauty of these simulations, right? We should all have different. That's the way it should be. So, there we go. Okay. That's me a 1, 2, 3, 4, 5, 6. Yeah, I draw a line. I'm learning. Okay, so we're gonna do this is 10, this is 20, 30, 5 marks here. Okay, so I had 9 ones, so that's gonna be over here. Okay. I had 19 twos. Up there. Okay, I had 13 threes. So let's pass the 10 there. 13 threes, 14 fours, so just a little bit past the 13 right there. Okay, and then I had 23 fives. I think that's up to 20, 23 right up there. And then I had 22 sixes, so just a little bit lower. All right. There's my histogram right there. Easy peasy. Okay. Do me a favor. Raise your hand in the participants window. I'm going to lower all the hands here. Raise your hand in the participants window when you guys are done with your histograms. Okay, when you finish your histograms, raise your hand. Okay. You guys should be using your own results, right? Once again, raise your hand in the participants window once you are done with your histogram. Can you guys hear me? Okay. So are you guys still working on your histograms? Is that what it is? Got it. Okay. Okay. So I'm gonna, all right. Maya, you beat him to the punch. I need to clear this. All right. Thank you, Zoe, for raising your hand. Okay. Thank you, Hector. Thank you, Jordan. Thank you, Keon. Thank you, Daniel. Thank you, Andrew. And Ash, I'm pretty sure you're right on their heels. So drawing a histogram by hand is actually not that difficult, right? But if you have, if you do like a run of 500 times, those are some giant things that you have to draw. You have to go up all the way to, however many you need to go up to. It'll definitely be over 100 or something. So we can actually have create a histogram using RStudio. But we have to be careful, okay? So RStudio, with other times in histograms, it chooses our bin widths for us, right? It'll do like 1 to 3 or 1 to 5. And in this situation, I want to see each number individually. So we can actually put write a histogram code and tell RStudio the number of bins that we want, the number of bars that we want. And because of that, if I say like I want 6 bars, then it will make 1 bar per number, right? So in the histogram function, we can add the argument of number of intervals. So number of intervals, N-I-N-T, and we can tell it we want it to equal 6. And so this way, because we have numbers 1 through 6, it'll do 1 bar per number, okay? So we're gonna put N interval, or N-I-N-T, equals 6 at the end of our histogram argument so that it gives us 6 bars. Okay, so I want us to now go to RStudio, and we're going to create a histogram using our sample. Oh, sorry, did you still need that code? Okay. We're going to create a histogram using our sample. So we're going to do histogram sample 1. And I'm going to tell you this right now. It's going to give us a warning code, because usually when we're creating a histogram, we're using a numerical variable from a data set, right? So we have to do variable and then data equals whatever set. So because we're not using that format and we're just using sample 1, it's going to give us a warning code, but it should still give us our histogram. So when we put histogram sample 1, and then we're going to put N-I-N-T, so number of intervals, equals 6, because I want it to make 6 bars. Okay. And then I'm going to hit enter. And see we got the warning code there, but it still did it because it's not an error code. It's just a warning message. And I got my histogram here. Now my histogram will look different than your histogram. Will look different from each of your histograms. So if yours doesn't look exactly like mine, that's correct. It's how it should be. Every single one should be different, right? So in my simulation, I got a lot less 1s and a lot of 5s and 6s. But in your simulations, you might have them more balanced. No, not really? Okay, 3s and 5s, okay. So these are all the bar graphs of the simulations I've done in the past, right? You can see this one's pretty even. This was A. This was another A one. No, because it's just like flipping the coin, right? Every trial you do, every simulation you do, it's going to give you different results. Okay. So this is our latest one, this one right here. All right. Oh, nope, that's not what I want either. Okay. So we're going to actually stop here, okay? Because the rest of our lesson is essentially going to be you guys running these codes for die A and die B and making histograms to determine which die is biased and which one is unbiased, okay? And so we don't have enough time today, and I don't want to get started on it, and then you guys have to stop midway. So we're going to stop here. Make sure you have these codes available on Thursday when we come to class, because on Thursday, we're literally just going to go in and start experimenting and running the codes to see which one of our dies are biased and which one is actually fair. Okay? Any questions for today's lesson, guys and gals? Any questions? Right on. Okay. Okay, Lamar, you have a question about the homework. What's up? No, because our studio, the die in our studio are specifically six-sided die. So you would kind of just have to mentally think through the situations or write out the situations, right? If it's a four-sided die, then what's the probability of getting each side? 1 out of 4, right? And then it gives you different scenarios, right? Yeah. So you're just kind of working through those different scenarios just mentally. That's why I made it a four-sided die instead of like an 8-sided or anything, so that it would be smaller outcomes. Okay. All right, ladies and gentlemen. Other than that, have a great day. We will continue this on Thursday. And I hope you guys are good until then. Bye.